Hello everyone, my name is Akanksha Agarwala and this is Team 2 Deliverable 5 presentation on our project called Squander. For our agenda today, we will be going over our team members' details, then we will be talking about our project overview and personas. Then we will be discussing about the technologies we have used and the design architecture of our application. Then we will be going over our sprint recap followed by product backlog and sprint backlog. Then we will be demonstrating our project, the followed by a future sprint timelines, and then we will be talking about retrospective and end with our conclusion. So, as you know, our team is formed of five outstanding individuals with various backgrounds. So, our machine learning engineer is Nicholas Wong, who has designed the computer vision model architecture by training and evaluating the model performance. He has gathered representative image data for training the model. Next is our iOS developer Rajat Navafkar, who has designed and developed the Squander application. He has also integrated the machine learning model to provide specific results and also tested the Squander application to provide a better user experience. Then we have our cloud engineer Austin Blees, who has contributed to the architecture design of the project, where he has created an infrastructure as a code by integrating features and services. Then we have our full stack developer Suryadeep Nalana, who has contributed to design and development of the application layout. He's the author of the technical document of the project, and he has been working towards making our app user friendly. And here am I, Akanksha Agarwala, the project manager and the scrum master. I have made sure that I led the team meetings and kept the team on task. My responsibilities was to maintain the project's GitHub repository and wiki, and my responsibilities also were to document the test cases and co-author technical paper along with Suryadeep.
Overview problem statement. With the vast population of people around the world, the amount of waste produced has been gradually increased with the increase in population. On an average, the world produces 2 billion tons of urban solid waste yearly, and United States being the highest producer of waste among others. Around the world, the worst waste that is produced remains unprocessed due to lack of recycling knowledge with the people. So our scanner app overcomes this problem by producing a complete solution to organize and plan the disposal of waste through image recognition technology using a machine learning algorithm to detect the recyclable waste from image and produce proper disposal. With our app, we make people to be responsible and contribute to make this world a better place. Project description. Our Squander application is an image-based waste detection mobile application. It is worked by a user submits an image to the application, and a trained machine learning model runs on the image and gives results and information. The application is a simple tool to detect our waste with best accuracy results and easy steps to undergo the process in the application. And one more thing, why you should use the application is it provides a nearest recyclable location along with the rates and option to schedule a pickup persona. Uh, Jim is a 32-year-old. He's an event organizer. He has organized many big parties. He takes all the responsibilities such as handling the decoration of the event and catering the food. Is company particularly known for the food that is served to the people, that is tasty and hygienic food. After the party ends, the food that is left should be trashed carefully, and it is done by Jim. Jim can do this easily with Squander application by taking the image of his trash and finding all the information of what kind of item can be trashed that is found within the image where He can also know the information of where this trash can be dumped, or he can also schedule a pickup from the nearest factory location on this application. Simon is a mechanic. His age is of 35 years. He inspects the vehicles like cars, motorcycles, and light trucks that comes to his garage for a repair. Uh, he work His work provides a lot of metallic waste in a day that comes from repairing the vehicles. And this metallic waste can be taken by a recycling company, and Simon can make money out of it. He can contact the recycle company and have a deal using the Squander application. David has retired from his sales executive job recently after providing more than 30 years of his experience service. Uh, he was successful in his field and has been inspiration for others. After the retirement, he wanted to get his house renovated. Now he's passing his time by involving in the construction works with something he can do. So with Spanner app, David can participate in cleaning the construction waste from the site that can detect the waste material and find the nearest recycling company location to trash the waste by keeping the environment at a better position. Minimal viable product. MVP. The application is a process with machine learning model that recognizes the waste items in the image that is uploaded to the application. The model responds with confidential values on labels of recognized waste items and give results of waste items that is found in the image by categorizing how many of it. After this, the application provides an easy way for finding the nearest recycling company location to take the waste or schedule a pickup. Project requirement. Uh, Project requirement is to upload image and detect the waste from it that can be classified into categorizing what the type of the waste with the results receiving from the model.
Technologies that we have used in the project. So one of the main technologies that we capsulate our project in is Python. So we have our whole integrations and also the AI model written using Python and related libraries. And one of the most important one is the TensorFlow, which is a uh, machine learning and artificial intelligence package that's provided by Google. So we also use as Keras. So Keras encapsulates TensorFlow um, to provide more easily configurable modules and also enables us to use TensorFlow more as a template using Keras functions, which would take care of almost most of the configuration requirements, making it easy for the developers to deploy complicated neural networks or machine learning models. Another integration that we have with our application is Google Maps. We have Google Maps integrations to allow us to find the nearest recyclable locations. And we also are using um, iOS development kit for the front-end mobile application. So in the iOS development kit, we have an integrated core ML that comes with the iOS development kit, which has um, which has a very um, um, configurable out of the box machine learning models available for us to use. So this enables us to do a primary machine learning use case inside the front-end model before the image actually gets sent to the backend. Then we have Swift. Swift enables us to design the application in a user interactive way, improving the user experience and also ensuring that um, the compatibility of the application is using a lot of native resources that's available um, in the platform. For example, we have Swift enabling notifications for the iPhone, ensuring that the notifications behave in the way that native notifications are designed to behave. And also we have different security screening that Swift enables us to do without doing too much integrations or too much coding. So that has been a great help for us. And lastly, we have CloudFormation. So CloudFormation is an infrastructure as code um, solution that's provided for us from AWS. So the CloudFormation also allows us to configure the whole infrastructure using infrastructure as code, and also provide with a lot of template that enables us to make easier integrations between the backend and all the uh, dependent services. It also enables us to integrate and provide provide a user accessible API endpoint and security screening on it. Also, CloudFormation templates allows us to ensure that we comply with the auditing and the security standards of AWS that has been mandated. So, using a template ensures that all of these security and logging practices are already engraved into the application. So, let's dive deeper into the architectural design. So in here we have two perspectives. One is from the perspective of a user, and the second one is from the perspective of a developer. Um, so let's go through from the perspective of a user to start with. So we have the user using a mobile application. In our case, it's an iOS application, which inside uses an MVC architecture. So the model view controller allows us to make instant decisions and also update a particular page of the application based on users' interaction um, with the view that they have. So MVC also ensures that the application is responsive to any input that the user gives, and also it ensures that we are screening the users from unwanted informations, um, and keeping the application simple. So that's the MVC architecture there, and then we have once the user uses the application, then the the services that we have hosted and the backend that does the image processing, and also that figures out what's the nearest receivable location which has been deployed in AWS. So that's the second box that you see there. We have an Amazon machine learning model, or Amazon SageMaker, that runs our machine learning model. And the SageMaker is integrated with the S3, where the photos that the users click are uploaded to. And all of these are integrated with CloudWatch and CloudTail. This ensures that all the applications have proper logging and auditing compliance. So the CloudWatch and CloudTail part of the infrastructure comes with the CloudFormation template. You could also see the AWS Code Deploy. Code Deploy ensures that the application has been deployed with CloudFormation and all the resource is required to function the application has been deployed properly and ensures that all of them are in an active state. We also integrate IAM permissions into the infrastructure to ensure that we do not get.
Thank you, Austin. Now I'll be talking about the algorithm our model uses. Our model takes an image and splits it up into pixels. Each pixel is passed through as a neuron in our input layer. Then the information is passed through several hidden layers leading to our output layer with confidence values for each of our chosen classes. In this case, we have plastic, cardboard, and trash, but in our actual algorithm, we have several more classes. This is how we get a result for the model, and the class with the highest confidence value is how we get our classification. Next, for our classification, our model is able to recognize 6 types of trash: cardboard, glass, metal, paper, plastic, and miscellaneous trash. These are the classes we chose because they add up to be a pretty comprehensive overview of in garbage in general, and the classes align with the image data publicly available to us. On the right, you can see some of the test images we used to train the model. Now to go over our model evaluation. We can see the training went well with a very high accuracy, but the validation accuracy is a little bit low, hovering under 80%. We'll be looking to improve on this in future sprints with a combination of pre-trained models and additional training data. However, looking at the left, we can see a good example of how our model works and how it gives us an output. We can see that the bottle is glass, and the model tells us this image is most likely glass with a 100% confidence value. Next, I'll also be going over our sprint overview. First, to look at our burn down chart for sprint 4, we can see the effort and trend line are very close together, so we were able to stay on track for the last sprint. Next, I will be talking about our sprint overview. First, to look at our burn down chart for sprint 4, we can see that the effort and trend line are very close together, so we are able to stay on track during our last sprint. Looking at our completed tasks on the left, last sprint was a lot of wrap up. We finished up a lot of the UI design and we were able to meet our MVP for last semester. To give a brief overview on what we did during our last sprint, we finished the first iteration of our application UI design. We deployed our model solution into our application architecture, and we were able to have our model recognize a larger range of trash. In our current sprint, we are looked to lay down some foundational work so our future sprints will run more smoothly. To do this, we wanted to determine and map out our goals for future deliverables, and we wanted to research the necessary technologies to achieve those goals. We were also able to develop our navigation bar feature, which is now in our application, and we were able to improve our confidence values in our model. Now to talk about our improvement from last sprint to this sprint. We want to improve both technically and with our presentation skills. From a technical standpoint, we wanted to improve our interface and add additional content for users. We also wanted to improve our model with multiple entity recognition and more accuracy, and we wanted to improve our maintainability of the project with a few architecture changes. From a presentation standpoint, we want to try to be more concise in our presenting, and we want to have more energy when we give these presentations. Next, I'll be handing this off to Austin to talk about our backlog.
So I'll be taking through the backflow for this application that we have. So the main sprints or user stories that we focused on this sprint are from Simon. Simon being a mechanic, he had a requirement that the application would be available throughout the locations in the US. Why he needed was because he would be traveling for his work related activities throughout the US, and he would still like to use the applications to find locations that he could drop the recyclables off. And we have David. He's a retiree, and he works on home projects and DIY stuff. So he generates a lot of recycled waste, and he would like to be green to the planet. So he would like to contact the team so that he could either request for new features, or he could either give feedbacks to the features that we currently have. David is a very great addition to our user base because he would push us to give our application more user experience and simplified user interfaces. And Mark, he's a homeowner, and would he currently be in an user per application? He requires the applications to do more than what it currently does. So Mark requires the applications to get more items in the images that he upload. Um, so why he requires that is that he would like to take a larger image of the items in his house, and rather than taking smaller pictures of each sections. So he would like to get his job done quickly, and he requires the model to be able to identify more images per each pixel. And John, he's an engineer, and he also is a user of the application. What he is more concerned about is the accuracy of the model, and he would like to make sure that whatever that's classified has a higher true positive rate, and ensures that the application detected are what they are. So he pushes towards making sure the application have or the model have a higher accuracy. Going through the task sprint stories and the tasks or the um, um, enablers for this project. They are, one is for Simon and then other one is for David. And we also have other enablers as in GitHub updations, wiki page updations, technical page updations. We also worked on ensuring that these deliverables are met on time with sprint meetings. So if you take a look at the bone down chart, you can see that there is a gap in the expected story points from the sprint, meaning that we still have two tasks pending, and we currently are experiencing an spillover. Um, so talking about spillover, we're focusing on what stories we could focus on until the next sprint. We have the spillover stories from this current sprint, which is about the maintainability of the application, and that's about making sure the AWS resources can be easily deployed. And also we have a spillover task from this current sprint, which makes sure the model accuracy is improved substantially. And then we have a new task where we focus on the scenarios from Mark, Simon, and also ensuring that we have a proper AWS infrastructure built, and we are using CloudFormation for that. So we need to design and deploy an AWS endpoint that allows any third party to use our application without installing our mobile application. We have to still work on the Google Maps integrations for location and recycling. We also need some work to be done on the UI UX to make David the required more user friendly with our application. And we also have the paperwork that need to do with the project. That's the a technical paper manually from GitHub. So those have to be done on every sprint. Thank you, guys.
Hello everyone. Now I will be going over the test cases. As in this sprint, we have added a new screen about us. That is about us. So, the in the about us test cases, the we want to locate the info button which will be in the home screen. So the user should be able to see the info button in the home screen navigation bar, and it should be clickable. And as we see in the home screen, the info button is visible, and once it is clicked, it is redirected to the about us screen, and this test case is a pass. And then we want to locate the recycle location link in the about us screen, and we see that the recycle location link is there and it is clickable, and once we click on that, it is taking us to the recycle location, and this is pass again. Then we want to know about the contact details of the team, and we locate about the contact detail link, and it is also clickable, and once the link is clicked, it is redirected to the team information, and this is again a pass. Then then the last test case is locate the back button. So the user should be able to see the back button in the About Us screen, and it should be clickable. And once the user click on the back button, then it redirects the user to the home screen, and it is pass again. Now, I will be going over the velocity chart. As you could see, the velocity chart is of what was committed and what is completed. So, as we see in the sprint one, we committed that we will be working on 20 user stories, and we completed 20 user stories point. And in sprint 2 we committed 41 story points, and we completed 41 story points. In sprint 3 we committed 27 story points, and we completed 27. And sprint 4, which was the longest sprint, as we worked majorly on that sprint, so the story points that was committed was 45, and we were able to deliver the 45 sprint. And sprint 5, we we committed 38, but we could only complete 34, because there were few in progress tasks that was not able to be completed in our current sprint, which is sprint 5, and which is now spilled over sprint 6. So in our velocity report, as you could see, the green chart, the green bar represents the committed or the estimated story points, and the blue bar graph indicates the completed story point.
Hello everyone, my name is Rajat Nagavkar and I will be showing the project demo. So this is a Squander project developed in Xcode. So I will first run it. As you can see, the application is launched and we are able to see the home screen. So till now we are able to recognize a single atom by pressing this earth image, and that will show us two options, that is camera and photo library. Once we click the photo library is open, and once we click the image and select it, we are able to get the confidence value of the atom which is found in that image. In this print, we have added one new feature, such as adding an info button at the top, which shows information about the app, about what Squanter application does, and how to use that app. And also it gives information about the nearest recycling location, such as if a user want to know about the nearest recycling stations, then he can click in the nearby recycling location, and he will get or navigated to that screen. And if you want to join any curbside program in his vicinity or something, then he can press the curbside program and get navigated to that screen. And at last, we have also included features such as contacting the Squander team. Uh, if a user is impressed with the idea of a Squander app, and if he wants to connect with the team of the Squander, that he can press this contact team, and he will get navigated to the contact to the contact screen. uh, so, till now, we are in this sprint. We are only able to give information about the app, and in the next sprint, we'll be able to show the recycling locations nearby to the user location, um, so that the user will be able to recycle items nearby to its location. Thank you. Hello everyone. Now I will talk about retrospective. This time, what went well is that we had deliverable deadlines, and we were able to meet the deliverable deadlines on time and deliver properly. Also, we had a talk distribution and Scrum Master resolving blockers. So this time, what needs the improvement we needed is that we need to maintain code properly, so that the reusability of the code is increased, and we need to commit story points with the velocity, so that there is a no gap between what amount of stories we made and our speed. So there must be a comparability between the stories we made and the pace we are taking about. The future actions, what we are going to take overcome this, that to reduce the technical debt by getting more knowledge about the technical terms which are using in our project, and also a better estimation of the deadlines, so that we will be able to deliver the deliverables uh, on time. Thank you. Hello everyone. I'll be concluding this sprint presentation, and in this first I will give you the application recap that tells about what till now the app does, and in the future what are the scope of this app. So in the application recap, till now the Squander app can recognize a single item from an image and categorizes it into categories such as cardboard, glass, metal, paper, plastic, and miscellaneous trash. And it also provides information about the app, such as its use and the various recycling links which the user can use to find the recycling stations. The app provides the model results, the information on the wastage, the location of the nearest recycling factory. So in the future, we will be concentrating on improving the model accuracy to detect more waste by increasing the quantity of training data, and to implement enhanced learning, object segmentation, and multiple object recognition. Uh, uh, what does it mean? That we are trying to detect multiple object from an image, and so that the more number of items are recognized and shown to the user. So following to it, we will be showing recycling locations nearest to user location, and adding more features to the application such as scheduling and environmental impact tracing. And at last, we'll be keeping track of users' contribution towards waste recycling. Thank you.